Hello there, Scott again from EdgeMath. I've got a question about central limit theorem for means from a student, and that has to do with, so let's say we've got to illustrate with an example, let's say we've got a population that has an average height of 70 units, or 70 inches. So we try to draw this on the graph. So if they've got an average height of 70 inches, so we've got 70 inches here, and the heights are centered around that, and we can assume it's a normal population, so it follows the bell curve, i.e. with standard deviation 3 inches, so that's one standard deviation plus 3, so 73. And then one standard deviation to the left would be 67. And then, just to review what standard deviation means, that means that for one standard deviation, you can look at the table, but that means 34% of the heights of the population will be in this range, i.e. the mean to one standard deviation above the mean. That's always true for if we have whatever the standard deviation and mean of a population is, but if it's normally distributed, like it follows the bell curve, that's true about it. So 34% of heights will be in this range. So if we take, or if we pick a random person, the probability is 34% their height will be in that range. But if we take 1,000 people and we measure the means of those, we would, like if we take 1,000 people, that's going to give a much more accurate picture of the population. It's going to, the mean of that will be much closer to 70, so the mean is going to be the same because we're drawing people from the overall population, so we'd expect the mean to be about 70, just the same as the overall population. But we'd expect the distribution of the possible means of a sample to be much closer to 70. Again, because we're taking so many people, it'll give a better picture of the population. So it's going to look the same, but it's going to be much tighter around. The odds are much higher. It's going to be close to 70. So it's going to be a bell curve, but it's going to be squeezed down. That's not too accurate, but it's going to be around 70. And then the central limit theorem says that the standard deviation of the sample means, like if we purely take sample means and then measure the standard deviation of those, is going to be just the overall standard deviation. It's the population standard deviation divided by the square root of the number in the sample. So here that's the overall standard deviation is 3 inches, and we're taking a sample size of 1,000, quite big. So that's going to give, that should give an accurate picture of the actual mean. So we take 3 and divide it by square root of 1,000, and we get the standard deviation is 0.09. So actually, if we take a random sample of 1,000 people, we'd expect, so instead of 34% on average to be between 70 and 73, we'd expect 34% to be between 70 and 70 plus one standard deviation, so 70.0936. So it's going to be very tight around 70. And that's what the central limit theorem says. There's some more detail in the overall statement, but that's basically the gist of it. Great, so I hope that makes sense, and let me know if you have any questions, and have a great day.